Article 300.4d addresses the protection of cables. This specific requirement states that where cables are installed in raceways, boxes, or other enclosures, the cable sheath shall be secured to the raceway, box, or enclosure to provide electrical continuity and strain relief. An air handler is considered an enclosure. When the insulation of a Romex power cable is cut, it compromises the integrity of the cable sheath and its ability to provide electrical continuity and strain relief. To comply with the National Electrical Code, a Romex connector must be installed at the point of entry into the air handler. The purposes of this connector are threefold. Firstly, it must protect the damaged cable sheath. Secondly, it must provide electrical continuity. Thirdly, it must ensure strain relief. An alternative to a Romex connector is a bushing. However, a bushing would only provide protection for the cable sheath. It would not provide electrical continuity or strain relief. Therefore, the National Electrical Code requires a Romex connector to be installed at the point of entry of the Romex cable into the air handler to ensure compliance with Article 300.4d. Electrical continuity refers to the uninterrupted flow of electrical current through a circuit. In the context of cable installations, maintaining electrical continuity is crucial for safety and proper functioning of electrical systems. The cable sheath, typically made of a conductive material, serves as a grounding path. If the sheath is compromised, electrical continuity may be disrupted, potentially leading to ground faults and electrical hazards. Strain relief refers to the mechanism that prevents mechanical stress from being transmitted to the electrical connections within a device or enclosure. Cables are often subjected to pulling, bending, and twisting forces. Without adequate strain relief, these forces can damage the cable, its terminations, or the equipment to which it is connected. Strain relief is typically achieved through the use of connectors, clamps, or other devices that secure the cable and absorb mechanical stress. The National Electrical Code, or NEC, is a widely adopted standard for the safe installation of electrical wiring and equipment in the United States. It is published by the National Fire Protection Association, or NFPA, and updated every 3 years. The NEC provides comprehensive guidelines for electrical installations covering topics such as wiring methods, overcurrent protection, grounding, and equipment installation. Compliance with the NEC is essential for ensuring the safety of people and property. Article 300 covers general requirements for wiring methods and materials. It provides rules for the installation of conductors, cables, and raceways. Article 300.4 specifically addresses protection against physical damage. It outlines requirements for protecting conductors and cables from abrasion, impact, and other forms of physical stress. Subsection D focuses on the protection of cables entering enclosures. An enclosure is a box, cabinet, or other housing that is used to protect electrical equipment from the environment and to prevent accidental contact with live parts. Air handlers, junction boxes, and electrical panels are examples of enclosures. When a cable enters enclosure, it is important to ensure that the cable sheath is properly protected and secured. The cable sheath is the outer covering of the cable which provides insulation and protection for the conductors inside. If the cable sheath is damaged, the conductors may be exposed to moisture, dust, or other contaminants, which can lead to electrical faults and equipment failure. Furthermore, a damaged cable sheath can compromise the grounding path, increasing the risk of electrical shock. To prevent these problems, the NEC requires that the cable sheath be secured to the enclosure in a manner that provides electrical continuity and strain relief. This can be achieved through the use of a Romex connector or other approved fitting. A Romex connector is a type of fitting that is specifically designed to secure Romex cable to an enclosure. It typically consists of a plastic or metal body with a clamping mechanism that grips the cable sheath. A connector is installed in a knockout hole in the enclosure, and the cable is then inserted through the connector and clamped in place. A bushing is a type of fitting that is used to protect conductors or cables from abrasion as they pass through a hole in an enclosure. It typically consists of a plastic or rubber ring that is inserted into the hole. The bushing provides a smooth, rounded surface that prevents the cable from being damaged by the sharp edges of the hole. While a bushing can provide protection for the cable sheath, it does not provide electrical continuity or strain relief. Therefore, it is not a substitute for a Romex connector in applications where these functions are required. In the case of a Romex power cable entering an air handler, a Romex connector is required to comply with NEC Article 300.4d. The connector must be properly installed and tightened to ensure that the cable sheath is securely clamped and that electrical continuity and strain relief are provided. It is important to select a Romex connector that is appropriate for the size and type of cable being used. The connector should also be listed by a recognized testing laboratory, such as Underwriters Laboratories or UL, to ensure that it meets safety standards. When installing a Romex connector, it is important to follow the manufacturer's instructions carefully. The knockout hole in the enclosure should be the correct size for the connector, and the connector should be properly tightened to prevent it from coming loose. The cable sheath should be inserted into the connector far enough to ensure that it is securely clamped, but not so far that it interferes with the conductors inside. After the connector is installed, the cable should be inspected to ensure that it is not damaged or strained. The cable should also be tested to ensure that electrical continuity is maintained. If any problems are found, the connector should be reinstalled or replaced. In summary, NEC Article 300.4d requires that cable sheaths be secured to enclosures in a manner that provides electrical continuity and strain relief. In the case of a Romex power cable entering an air handler, a Romex connector is required to comply with this requirement. The connector must be properly installed and tightened to ensure that the cable sheath is securely clamped and that electrical continuity and strain relief are provided. Failure to comply with these requirements can result in electrical hazards and equipment failure. Always consult with a qualified electrician to ensure that electrical work is performed safely and in accordance with applicable codes and standards. Choosing the right Romex connector. Romex connectors come in various sizes and materials to accommodate different cable sizes and installation requirements. Selecting the appropriate connector is crucial for ensuring a secure and compliant installation. Firstly, consider the cable size. Romex cables are available in various sizes such as 14/2, 12/2, and 10/2, where the first number indicates the wire gauge and the second number indicates the number of conductors. The Romex connector must be sized to match the cable size. Using a connector that is too small can damage the cable sheath, while using a connector that is too large can result in a loose and insecure connection. Secondly, consider the enclosure type. Enclosures are typically made of metal or plastic. Metal enclosures require connectors that are listed for use with metal enclosures, while plastic enclosures require connectors that are listed for use with plastic enclosures. Using the wrong type of connector can compromise the integrity of the installation and create a safety hazard. Thirdly, consider the environment. In damp or wet locations, use connectors that are rated for wet locations. These connectors are designed to prevent moisture from entering the enclosure and damaging the electrical components. Fourthly, consider the ease of installation. Some Romex connectors are easier to install than others. Choose a connector that you are comfortable working with and that can be easily installed in the available space. Common types of Romex connectors include clamp-type connectors and screw-type connectors. Clamp-type connectors use a clamp to secure the cable sheath, while screw-type connectors use screws to tighten the cable sheath. Both types of connectors are acceptable, but clamp-type connectors are generally considered to be easier to install. Installing a Romex connector. Proper installation of a Romex connector is essential for ensuring a secure and compliant installation. Follow these steps to install a Romex connector correctly. Firstly, turn off the power. Before working on any electrical wiring, turn off the power to the circuit at the circuit breaker. This will prevent electrical shock. Secondly, prepare the cable. Cut the Romex cable to the desired length and remove the outer jacket to expose the conductors. Be careful not to damage the conductors. Thirdly, insert the cable into the connector. Insert the Romex cable into the Romex connector, ensuring that the cable sheath is fully seated in the connector. Fourthly, tighten the connector. Tighten the Romex connector according to the manufacturer's instructions. Be careful not to over-tighten the connector, as this can damage the cable sheath. Fifthly, secure the connector to the enclosure. Insert the Romex connector into the knockout hole in the enclosure and tighten the locket to secure the connector to the enclosure. Sixthly, inspect the installation. Inspect the installation to ensure that the Romex connector is properly installed and that the cable sheath is securely clamped. Also, make sure that the electrical continuity is maintained. Common mistakes to avoid. Several common mistakes can occur when installing Romex connectors. Avoiding these mistakes is crucial for ensuring a safe and compliant installation. Firstly, using the wrong size connector. Always use a Romex connector that is sized to match the cable size. Using a connector that is too small can damage the cable sheath, while using a connector that is too large can result in a loose and insecure connection. Secondly, over-tightening the connector. Over-tightening the Romex connector can damage the cable sheath. Tighten the connector according to the manufacturer's instructions. Thirdly, using the wrong type of connector. Use connectors that are listed for use with metal or plastic enclosures and are rated for wet locations if applicable. Fourthly, failing to secure the connector to the enclosure. Secure the Romex connector to the enclosure by tightening the lock nut. This will prevent the connector from coming loose and compromising the installation. Fifthly, damaging the cable sheath. Be careful not to damage the cable sheath when cutting the Romex cable or inserting it into the connector. A damaged cable sheath can compromise the grounding path and increase the risk of electrical shock. Sixthly, neglecting electrical continuity. Ensure electrical continuity by properly installing the connector and checking with a multimeter. Troubleshooting Romex connector problems. If you experience problems with a Romex connector, several troubleshooting steps can help identify and resolve the issue. Firstly, loose connection. If the Romex connector is loose, tighten the lock nut to secure it to the enclosure. If the connector is still loose, replace it with the new one. Secondly, damaged cable sheath. If the cable sheath is damaged, replace the Romex cable. Thirdly, electrical continuity issues. If you are experiencing electrical continuity issues, check the Romex connector for loose connections or corrosion. Tighten any loose connections and clean any corroded surfaces. If the problem persists, replace the connector. Fourthly, water damage. If the Romex connector is exposed to water, dry it thoroughly and replace it with a connector that is rated for wet locations. Remember to turn off the power before working on any electrical wiring. When in doubt, consult with a qualified electrician. Additional NEC considerations. Beyond Article 300.4d, other NEC articles may be relevant to Romex cable installations in air handlers. Firstly, Article 314 covers outlet, device, pull, and junction boxes, conduit bodies, fittings, and handhole enclosures. This article provides requirements for the installation of boxes and enclosures, including requirements for box fill, conductor bending space, and support. Secondly, Article 320 covers armored cable types AC and MC. Although not Romex cable itself, understanding armored cable requirements can provide context for proper cable protection methods. Thirdly, Article 334 specifically covers non-metallic sheaths cable types NM, NMC, and NMS, which includes Romex cable. This article provides requirements for the installation of Romex cable, including requirements for support, protection, and ampacity. Fourthly, Article 430 covers motors, motor circuits, and controllers. If the air handler contains a motor, this article provides requirements for the wiring and protection of the motor circuit. Staying updated with NEC changes. The NEC is updated every 3 years, so it is important to stay updated with the latest changes. This can be done by attending training courses, reading industry publications, or consulting with a qualified electrician. Changes to the NEC can affect Romex cable installations, so it is important to be aware of these changes to ensure compliance. In conclusion, ensuring proper protection of Romex cable at the point of entry into an air handler is paramount for electrical safety and compliance with the National Electrical Code. Article 300.4d mandates the use of a Romex connector to provide both electrical continuity and strain relief, safeguarding against potential hazards arising from damaged cable sheaths. While bushings may offer some protection, they fall short of meeting the comprehensive requirements outlined in the NEC. Selecting the appropriate Romex connector involves considering cable size, enclosure type, environmental factors, and ease of installation. Careful adherence to installation guidelines, including turning off the power, preparing the cable correctly, and securely fastening the connector, is crucial. Avoiding common mistakes such as using the wrong size connector, over-tightening, and neglecting electrical continuity is essential for a safe and effective installation. When troubleshooting Romex connector issues, inspecting for loose connections, damaged cable sheaths, and water damage can help pinpoint problems. Additionally, staying informed about relevant NEC articles and updates ensures ongoing compliance with the electrical codes. Remember, when in doubt, consulting with a qualified electrician is always recommended to ensure electrical work is performed safely and to code.